All right, this video deals with the equation of a circle. So if, we can graph circles just like we can graph lines and parabolas and all those sorts of things. There are functions that lend themselves to graphs that are circular in shape. So the main formula for the equation of a circle is x minus h squared plus y minus k squared equals r squared. Well, what do all of those letters mean? Well, xy is just a point on the circle, x comma y, any point on that circle. Now hk is the location of the center of that circle. So in this case, h is -6 and k is 8. And then r stands for the radius. There it is. And it looks like in this case, r equals 4. Now, of course, that radius is going to be the same length no matter where in the circle that it is drawn, because throughout a circle, the length of the radius is consistent. That's what makes the circle a circle. So let's get the equation for this specific circle based on this information. Well, x is always going to be x. We are going to subtract the x coordinate of the center. So in this case, we are subtracting -6. When we subtract a negative, we get a positive. We will write that like that. We will do our addition and our y. Now we're going to subtract k, which is the y coordinate of the center. In this case, it is 8. And we'll square it. And then we will square our radius. Well, 4 squared is, of course, 16. So we're going to finish off the equation of this circle with 16. Now, you'll notice, and this is kind of a tricky thing to remember with circles, because of this subtraction in here, the sign within the parentheses, the signs within our parentheses of any equation is going to be the opposite of the signs of the things in the center, the coordinates of the center. So -6, 8 yielded x plus 6 and y minus 8. And that's just because those binomials that we are squaring are built on subtraction. So we just have to get used to the fact as we work with this equation that those signs are going to be the opposite of the signs of the ordered pair, if that makes any sense. So let's get some practice using this formula in a few different ways. Here we have an example where we're asked to graph a circle given its equation, x minus 1 squared plus y minus 3 squared equals 16. Well, let's get busy. And we are first going to start by plotting the center. So because, of course, we remember that these signs are opposite of what they are, we can see that our center is going to be +1, +3. So that happens right there. Now we need to find the radius. Well, r squared is 16. So the radius is going to be the square root of 16, which is 4. Won't always be an integer in every circle, but this time it is. So now how can we put that radius into action? Well, I'm going to suggest that you do it by graphing points in each cardinal direction, north, south, east, and west, up, down, left, and right, from the center. So if I go to the right 4, I'm going to get that point right there. If I go up 4, I'm going to land there. To the left, I'm going to go there. 2, 3, 4. And down, I'm going to go there. And then we're just going to do the best we can here. It's all we can do. It's not terrible. And there you go. A word about this formula, by the way, is that this is built on the Pythagorean theorem. So if I wanted to find, here's a random point, x comma y, on our circle. Well, we get to that point by going over and up. And so we've made a nice little right angle there. So the x coordinate of our random point on the circle is the difference between, well, the distance here, the x distance, the sideways, is the difference between the center and the x coordinate. So that's why where this x minus, in this case, x minus 1 comes from. And then the up and down distance is the difference between the y coordinate of the center and the y coordinate of our point. That's why it's y minus 3. And then the hypotenuse of this little right triangle we've just created is the radius, r squared. So the relationship between these 2 points can be categorized kind of like the Pythagorean theorem. So that's why we have x minus 1 squared, y minus, in this case, 3 squared, and then radius squared. So as you're trying to remember this formula, just remember that it is built on the Pythagorean theorem. That may be helpful as you try to commit this equation to memory. Let's see another example. Here we're going to write the equation of a circle whose center is at 5, negative 4, and has a diameter of 14. Okay, first thing we can see, we have we have the diameter. So if the diameter is 14, the radius is going to be half of the diameter, which is 7. Diameter goes all the way through the shape, through the center, from one side of the circle to the other, and the radius just goes from the center to the outside, so it's half of the diameter. Well, we're going to start with x minus, and in this case it's x minus 5, and then we'll square it, plus y minus negative 4. So minus a negative is plus a positive. And we finish that off. And then the other side of the equal sign, our hypotenuse, if you will, is 7 squared, which is 49. And it's really that easy. And again, you can see the signs are opposite. So this is a minus, but it indicates a x coordinate of the center of positive 5. And then these are negatives as well. They are opposites as well. Finally, we are asked if a certain point lies on this circle. Well, this is meant to be a point on the circle. It is xy perspective. So we're going to plug this into our formula and see if it gives us a true statement. So let's try it. 11 is our x. And we can see where that's going to go. 3 is our y. So we have 3 minus 6 squared. And that will equal 9 if it is a point on the circle. Well, here we've got 0 squared, which is just 0. Here we have negative 3 squared equals negative 9. And so this is going to be 0 plus, we square a negative and we get a positive. And this is a true statement. So does 11,3 lie on this particular circle? Why, yes, it does. If we had gotten a false statement when we plugged it in, it would have not been on the circle. So that's a few different uses of the circle formula. I think you'll find, hey, you might accidentally memorize this formula just by working so much with it. But I'm going to do a few different videos here pertaining to circles in the next few days. So take a look at those, and they'll be there to help you when you need it. You're working hard. Thank you very much for watching, and I hope it was helpful. Take care.